So October, November 2019, P21. Question number 1. Question number 1 says, study the following pseudocode. Function search returns integer. Function search returns integer. Declare n and c as integer. These are local variables. V and c as real. These are local variables. V is equal to get level. L is equal to V into 1 point. Yes, Arif, bilkul hai. L is equal to V into 1.34. C is equal to 0. For n is equal to 1 to 10, we get level. If V is greater than L, then C is equal to C plus 1. And for, remember, and for is no more. We have to use next instead of and for. Output process complete, return C and function. This pseudocode lacks features that would make it easier to read and understand. All right, to read and understand. Now we have to state that what are such features. First of all, we are never allowed to use A, B, C, D, L, C, V as name of the main variables. So the first feature that we have to have is sensible identifier or variable names. Okay, sensible identifier or variable names. Okay. Secondly, we don't have blank lines here. I always tell you that after declaration, after initialization, before for next, after for next, before return, you should leave few lines so that people have clear readability. They have clear reading. They have improved readability. So you can say blank lines. There is another feature which is absolutely necessary that is used here, but that is indentation. Indentation is there. Okay, so blank lines, we have to put blank lines there, and then the use of comments. If we add these three features to this particular code, this code will become more readable, more understandable, better. And remember, when you write program in exam, you should use, other than comments, as many features as. बेटे pretty print जो है ना वो हमारा feature नहीं है, वो editor का feature है. Pretty print is IDE feature, not R. So pretty print is done by the IDE, the editor itself. Okay, so all we have to do is to, when we write, we should care for these things: indentation, sensible identifier names, and blank lines. That pretty print thing, first of all, it is a single word. Secondly, it is done by the computer itself. That is not us. Okay, so you don't have to write comments in exam. Mind that. Draw a flowchart to represent the algorithm implemented in the pseudocode. Variable declaration are not required. So let's make the algorithm flowchart. Start, then declaration is not required. Then V is equal to get level. So it means get level is a subroutine which is being called. So we will make this box. This box is basically showing that a subroutine is being called. So V is equal to, we don't use arrows here, get level. So start V is equal to get level, then a separate box for L is equal to V into 1.34 and C is equal to 0. Since they both are simple processes, we can put them both together in one part, and then n is equal to 1 to 10. So we make n is equal to 1. This is the start of the loop. And then uh, is n is equal to 1, is v is greater than L, no, n is equal to n plus 1, is n is less than 10, yes, yes. If this is yes, then C is equal to, okay, we have this over here as well, this part. V is equal to get level over here. Okay, V is equal to get level. V is equal to get level, and if it is yes, then C is equal to C plus 1. C is equal to C plus 1, and then it will come back over here. Once it gets out from here, no, then it gives some sort of output, which is this, and then stop. This is rough made because of the lack of space over here, but that is how it will be done. So start, V is equal to get level over here, and then L and C are initialized over here with their values. For n is equal to 1 to 10, so n is equal to 1, then V is equal to get level. I have put it on in here, and then it checks if instead of if we use is V is greater than L. If it is yes, then C is equal to C plus 1. If it is no, then n is equal to n plus 1. N plus 1. Once that is done, then it checks is n is less than 0. If it is yes, it goes on and on and on and on and on. And if it is no, then it comes out, then it gives output, and then it returns C. Returns C. Returns C, and then end. Sir, get level हमने function call करा है. Yes, yes, Sarif. This is get level a function. Now, you get good 5 marks for it. Now, part B. Programming languages support different data types. Complete the table by giving a suitable data type for each of the following examples. First one is definitely it is a string. Second one is real, but it is in negative, but it is real. Negative or positive, both numbers can be real and integer. It doesn't make any difference. So why it is real? Because it has got this decimal part in it. Not false is Boolean. 132 is integer. Okay. Now we have to evaluate this. Evaluate means sort this out, execute this statement, whatever the result that you get, you put here. But if they say that evaluate each expression in the following table, if an expression is invalid, then write error. So left 3. So we take this STA, merge with right 3. So this will become STA PLE, staple. So this is basically the output of this is always a string. So be careful about putting these double quotations. Mid of sample 3, 5, 3, 5, 3, 1, 2, 3, 4. We have got 4 characters. There are no 5 characters. That is why it is error. Get the idea? What do they mean is start from the third character and pick up 5. So since if we start from third character, we have got only 1, 2, 3, 4. There is no fifth character. That is why it is error. Now, num to string means convert a string into integer. Sorry, num to string. Convert an integer or real, a number, regardless whether it is integer or real, and convert it to string. Sir, direct n का loop एक box में नहीं. No. So 12.3 into 2 will become 24.6, and when you convert it to string, it will become 24.6 in double quotation. Now, integer of string to number. So first of all, we have taken a string, we have turned it to a number, and then we added 7 to it. So 53.4 plus 7 is basically 60.4, and then we apply integer to it. So this will be 60. That's your answer. Okay, so be careful. Integer does not round, integer shades of decimal part. A structure chart is often used in modular program design. One feature is the sequence of module execution. Sequence of a module execution. What are other features? Now, let's first revise. So this is our one module. Let's say this is A module. It calls B module. Then it calls C module. Then it calls D module. Okay, so there are certain features of every computer program that we have. Those are sequence, iteration, or loops or repetitions, and selection or if then else or select. So sequence is from left to right. So A will call B first, means let's say if it is procedure A, it calls B, then it calls C, then it calls D, and then end procedure. This is exact depiction of this structure chart into this algorithm. So this is for sequence. Let's say I have these two in a loop. So I be like, while something is true and while. In this case, these two are being called again and again and again and again. Once this loop ends, then D will be called. So you can see that in these call B and call C are in between while and end while, and they are being repeatedly called. So this arrow from right to left, why right to left? It is not necessary, but right to left shows that a sequence is being followed. B and C, then come back. B and C, and then come back. All right, what RF says, sir, can you repeat the last part? Sequence is when you show algorithms, they are being solved from left to right. Left to right means first B will be called, then C, then D. Now let's say if we don't have this loop, all right, we don't have this loop, rather we have if condition. If x is equal to 9, and then and if. In that case, these two will be inside this diamond box. Okay, so these two will be inside this diamond box, because if the condition is true, only then C and D are being called, otherwise just B is being called first, and that's it. Okay, so I hope that you got the idea. This is one feature. Then we have hierarchy. Hierarchy. What is hierarchy? Hierarchy is that who is calling what is being called first. Okay, Arif, I'll tell you first. Let's finish this one. So A is calling B is calling something, A is calling C is calling something, A is calling D is calling something. So this is hierarchy. Who is calling what? That is hierarchy. And then we have parameter passing. Parameter passing, if it is by val, then it is simple data couple. If it is by ref, then it is this data couple. And if it is return, and if it is simple return, then this is this data couple. And if it is flag return, then this is this. This is called flag. So these are the features: sequence, iteration, selection, hierarchy, and parameter passing. Okay. So let's write these up. How many marks? 4 marks. So all we have to do is to put the name. Modular hierarchy. Number 2, sequence. They have already mentioned sequence. Iteration, selection, parameter passing, and that's it. 4 features. Identify and describe one feature of the IDE that can help with program presentation. The feature of IDE that can help with program presentation means that you have written a program and it is the code. Once the program is executed, IDE has nothing to do with it. Okay, the program is decoded, it is in machine language, it is being executed. IDE has nothing to do with it. IDE, when we programmers use the language integrated development environment to create, edit, debug, and compile the code. All right. Yes, Arif, it is now shifted to P1. Yes. So what are those? Now pretty print. Pretty print. Okay. IDE colors the code as keywords become blue and in caps string becomes red, etc. Okay. Other could be expand collapse blocks. Other could be dynamic syntactical. Dynamic syntactical program presentation. Auto correct, auto indentation. These are the features. Okay. By value is one method of passing parameter to a subroutine. Identify and describe one other method. So that is by reference. the address of the parameter is passed so that called subroutine also uses the same. This way, both argument and parameter are the same. Okay, so by reference में होता है context sensitive prompt. As in context sensitive prompt is editing. What they meant over here is presentation. The program is written. It is correct if someone reads it, whether they get it or not. So pretty print, autocorrect, auto indentation, they are best. Context sensitive help or context sensitive prompt, yes, it is a feature, but that is when we are writing a program. What if you present your program to someone, sir, ye padh le. Would sir be able to understand it or not? That is presentation. Okay. Now, explain the term adaptive maintenance. Adaptive maintenance is that your program is written, it is implemented, it is tested, it is working, and it is working all right. But because of the demand in companies, works and procedures change, and the changes in environment like government tax rate or something that needs your program to be updated accordingly, that is adaptive maintenance. So changes to the code made to update system as specifications work requirements are changed. Okay, now let's get back to the previous part. One student want me to explain this. Okay, so first let's take whatever that is inside, that is a string to number. So it means that this is basically a number, but it is a string. So first we have to actually change this string number into real form. So we have done it. 53.4. All right. And then we have to convert it to integer. Now this part, once we convert it to integer, it becomes 53. After that, this part plus 7, this will become 60. That is how it is done, Arif. Okay. All right. Question number 3.